Welcome back, student. The topic that will going to be discussed today is the test performed on transformer. Basically, there are two tests that are performed on transformer. One is named as open circuit test and the other is named as short circuit test. These both of these tests are performed on transformer in order to find the efficiency, regulation and the losses that are occurring in the transformer. Talking about open circuit test first. Open circuit test usually is done to find the excitation branch component. How open circuit test is done? First of all, the secondary of transformer is kept open. Here the secondary mean high voltage side. In open circuit test, the high voltage side of transformer is kept open and the primary or the low voltage side is connected with full line rated voltages. Mean the rated voltage of transformer is applied on the primary side and the high voltage side is kept open. A voltmeter and an ampere meter and a wattmeter is connected in the primary circuit. Now, as I told you earlier that open circuit test is done to find the excitation branch component. Excitation branch component include your resistance RC in branch with reactance XM. Resistance RC and XM are the component of excitation branch. Resistance component is the reciprocal of conductance and the reactance component is reciprocal of your susceptance. Both of these resistive component and reactive component, or I can say that conductive and susceptive component, are connected in branch or in parallel, so their equivalent impedance can be calculated as equivalent admittance, or impedance not equivalent admittance is calculated as G, which is your conductance minus your susceptance. Susceptance as imaginary part of the equation, or I can write the admittance as G is RC is reciprocal of G and XM is reciprocal of BM is reciprocal of XM, so I can replace G with 1 over RC and B with 1 over XM. How the admittance YE can be found? YE admittance is reciprocal of impedance. Admittance is reciprocal of impedance, so impedance can be found as admittance is reciprocal of impedance, mean Y is equal to 1 over Z and Z Y now will be equal to I over V, which is reciprocal of your impedance. Now, as the case here discussed is for open circuit test. In open circuit test, the current will be considered as I open circuit and the voltage will be considered V open circuit. So the equivalent admittance will become IOC divided by VOC, where IOC is the open circuit current and VOC is the open circuit voltage that are obtained by open circuit test. Or if we consider with current with the phase angle and voltage with the phase angle, your resultant admittance will become YE is equal to IOC divided by VOC with an angle of phase angle of minus theta. How theta can be found? As you know that the power in the circuit is given as VI cos of theta. Now P divided by VI is equal to cos of theta. theta is equal to cos inverse of P over Vi. This is the formula to find theta. Now for open circuit test, P is equal to POC, V is equal to VOC, and I is equal to IOC. So that's the way to find theta or the phase angle for your admittance. This is all about open circuit test. Now another test is performed on transformer, which is known as short circuit test. Short circuit test is usually performed by keeping the low voltage side short circuited. The low voltage side, secondary side, is short circuited, and the primary or the high voltage side is connected with a voltage. And these voltages are adjusted in such a way that these applied voltages on the high voltage side or primary side are adjusted in such a way that the current in the low voltage side or the secondary side become equal to rated current. The current or short circuit side or low voltage side become equal to rated current value. High voltage side is connected to a voltage source, and the voltage are varied such that the current in the low voltage side become equal to the rated current. Short circuit test is performed to find the series element including your resistance and reactance element connected in series. In open circuit test we have found admittance. Now we are going to find impedance. Impedance is, as I already told, V over ISC, VSC over ISC. ISC here stand for short circuit and VSC stand for short circuit voltages. ZSE mean your series elements impedance. Similarly, for finding the phase angle, we found phase angle by theta is equal to cos inverse of P short circuit, the short circuit power obtained by short circuit test, divided by I short circuit current, and V short circuit voltages. So your equivalent impedance become V short circuit over I short circuit with an angle of phase angle of theta. Now as impedance is equivalent to the sum of resistance and reactance, so I can write my impedance as R equivalent plus JX equivalent. Or referring to secondary side, I can write my equivalent impedance as RP primary side voltage plus A square, which is turn ratio square, into RS. Now I am referring my impedance from primary circuit to secondary circuit plus its equivalent impedance refer to primary circuit. This is how can you write the impedance in the circuit refer to primary side, or you can write simply the R equivalent and JX equivalent, which are computed by short circuit test. Now in order to fully understand the open circuit test and short circuit test concept, let us consider an example. In this example, it is required to calculate equivalent circuit impedance of a 20 kVA 8000 to 240 volt 60 Hz transformer. The open circuit and short circuit test of the transformer are given here. The results for open circuit and short circuit test are given here the voltages at open circuit test, open circuit current, open circuit power. Similarly, short circuit voltages, short circuit current, short circuit power are given here. We have to compute the equivalent circuit. For computing equivalent circuit, we have to compute the excitation branch element as well as series element. For calculating the excitation branch element, the open circuit values are used and the admittance is, and similarly the series element branch are calculated using short circuit test values. As you know, in open circuit test we compute admittance matrix, which is IOC over VOC with an angle of theta. Now theta can be computed by the formula given over here. Theta is equal to cos inverse of POC V over VOC into IOC. All of these things are given in question, POC, VOC and IOC. We just have to put the values in calculator and find its cos inverse. We will get the value of phase angle as 76.4 degree. Now you have computed the phase angle, you know the value of open circuit current and open circuit voltage. Just put the values over here, IOC, VOC with phase angle theta, which is 76.4 degree. Now put the angle in, put the values in this formula. You will get the equivalent admittance branch element, which is conductance and susceptance, equal to 0.0000629 minus, now this is your susceptance, this is your conductance, minus j 0.000259. This element is your conductance or G, and this element is your susceptance, or I can write as B. You know that R is equal to 1 over G and X is equal to 1 over B. So you calculate R and X by taking reciprocal of conductance and susceptance respectively. You calculate RC and XM, resistance and reactance of branch element. These are the values obtained by your open circuit test. Now short circuit test. Short circuit test will give us the value of our series element. Now for this we calculate impedance, not admittance. For impedance, the phase angle is computed similarly as computed in open circuit test. So put the values of short circuit power, short circuit voltage and short circuit current and take the cos inverse of these values. You will get the phase angle as 77.9 degree. Now put the value of short circuit current, short circuit voltage and phase angle theta for computing your impedance of series element. By putting the value in the formula, we will get the series element as 41, which is equal to R and R equivalent, and J 191.25, which is X equivalent. Now we have computed our branch, series branch and excitation admittance branch element. Now we can draw the equivalent circuit of transformer, which will be drawn like this. This is your excitation branch, and this is your series branch. So I will going to end this lecture here. Hopefully you have understood the concept of open circuit test and short circuit test. Thank you for listening.